Well, good morning, ladies and gentlemen. As Chris has said, thank you, Chris, for the introduction. I am the Business Development Director for Wood Energy. Wood Energy has been deploying biomass boilers in the UK since 2002, so we have a little bit of experience in the marketplace. We do wood chip and wood pellet boilers. I'll pop some contact details up at the end. If you want to visit us for discussion on any of these points in more detail today, we're at HEVAR on stand V1. My task in the next 15 minutes is to try and answer some of these questions for you. I'm going to explore what the Renewable Heat Incentive is. I'm going to just dwell for a moment on how it is different to Feed-in Tariff. Some of you may have had experience from solar photovoltaics in Feed-in Tariff, and this is a very different proposition, I would suggest. How do we make the most of it with biomass? One of the reasons I'm focusing on that is because, of course, I'm from Wood Energy, but also because if we look at the update that came from Ofgem just last month, over 80% of the installations that have been applying for RHI have been biomass. So at the moment, it's the technology that's looking to take the greatest share of the budget. I'm also going to think about what maybe if you were contemplating a biomass project, what you should think about in terms of the practicalities of actually getting the boiler out there, and also financial considerations, because now low carbon can make good financial sense. And then finally, I'm just going to show you some slides to prove this stuff is real and out there. So when it was launched, this was the table that came out for Renewable Heat Incentive, as Chris said, but for the sake of clarity, it covers biomass in terms of solid biomass, most predominantly wood chip, pellet, perhaps some what are known as energy crops, also small and large ground source heat pumps, solar thermal, and finally biomethane and biogas combustion. It's effectively the first scheme of its kind in the world. And economically, it's been designed to drive a more than tenfold increase in renewable heat over the coming decade. There's £864 million available from now until 2014 under the Comprehensive Spending Review. And to date, it's a significantly underspent number for this financial year. So essentially, payments are made to owners of renewable heating plant based on metered energy usage. So how many kilowatt hours you get out of your meter, which the next speaker will tell you a little more about, for a 20-year period. For biomass, it comes in 3 easy tariff bands, under 200 kilowatts, 200 to a meg, and over a meg. On the 2 lower bands, you do need to be thinking also about the split from Tier 1 and Tier 2. Tier 1 effectively represents a 15% load factor. It's ever so easy to remember. It's 14 kilowatt hours per annum. So for the first 1,314 kilowatt hours you produce of renewable heat from your biomass boiler, you will get actually not 7.6 but 8.3, because this is linked to RPI, and as of last month, those payments have been increased by the percentage that RPI has gone up. We'll see those later. The remaining hours that you generate in that year will be paid for with Tier 2 funding. So something around 2.1 pence currently. As I say, we're going to focus in on biomass, but first of all, let's just think, how is it different to Feed-in Tariff? If you've struggled with Feed-in Tariff projects on PV or been frustrated by some of the changes in regulation, just bear in mind that it is a little bit different to go after RHI and biomass. For Feed-in Tariff with photovoltaics, effectively you just need somewhere to put it. A roof or a ground site where you can get planning permission for the size of array you want to deploy, and a connection to the grid. So whatever you produce that you yourself don't use, you can export and be paid for. PV panels are essentially today a global commodity. The UK is just a small part of the world market, and we've seen what the significant increase in Chinese supply in the last few years has done to prices. So it's been relatively easy to set yourself up as an installer of PV. The key difference with RHI and biomass is you need a heat load. And that's what drives how much you can earn from the Renewable Heat Incentive. And you need to think about that load very carefully, because it's that load today, but for the next 20 years. The biomass boilers are more complex machines than PV. There's a few more moving parts, even if you take inverters into account. So they need to be looked at specifically for the application they're going to work on. There will always be some elements of site-specific design. Unfortunately, we can't get away from that. Planning will be important, and you have to prove that you either have spoken to the planning authorities or indeed secured permission before you can apply and receive your RHI payments. A classic example of a site-specific design would be height of flue, because that is dependent on the buildings around where your biomass boiler is going to be installed. Biomass boilers are incredibly automated machines these days, so please don't think we're talking about just log-burning stoves here. We're talking about auto-ignition, auto-de-ash, sophisticated control mechanisms. But they do need routine servicing. They not put them on the roof and forget for 25 years. And that its servicing is important because that's what's going to ensure your uptime and therefore your heat output and therefore your RHI payments. Another important point is that they're only as good as the fuel they burn. It's important that you put the right fuel in these sophisticated automated machines. Putting the wrong fuel in can cause you problems in terms of the machines actually stopping if they clinker up, or cause alarms that mean the machine has to stop. So it's important that you think about the fuel specification and don't be potentially suckered in by cheap fuel that actually turns out to cost you more than you imagined. So making the most of RHI, size the boiler appropriately. We've talked about the different tariff bands. It's important you do get the right frame size, but bear in mind there is a change in tariff as soon as you go over 199 and 999. It's also important that you get a good number of run hours. Obviously, we spoke about Tier 1, Tier 2. It's encouraging if you can get the full Tier 1 payments and then Tier 2 seen as a top-up. Important as well, you think about how little the biomass boiler can operate, insofar as your summer demand is going to be a lot less than your winter demand. Make sure your boiler can modulate down to what you need it to be, or you have another means of meeting a light summer demand. The RHI is modelled with what is known as the counterfactual fuel, i.e. the fuel you are displacing by using biomass. It is modelled on gas, and the whole incentive scheme is designed to give you a 12% rate of return on the difference in price between deploying the gas boiler and a biomass boiler. For those of you who are regularly paying energy bills, you'll know if you've got oil or LPG, that's significantly more expensive than gas today. So if you have multiple boilers on an estate portfolio, then we would suggest you displace oil or LPG before gas, because the rate of return will be above that 12%. Finally, I'm reiterating a point on this slide that I made a moment ago, but please do think about the right specification of boiler and the service package. Please ensure you can get somebody to site to help you bring a boiler back up to operation if it does have a problem over the 20 years of its operation to make the most of your investment. So how is biomass different practically from a gas or oil boiler? Well, if you look at the cubes I've shown in the picture there, each of those cubes actually represents the same amount of energy. So you can imagine if you had an oil tank, think how much bigger the wood chip store is going to have to be to give you the same amount of energy. So for once, gentlemen, size is important here. Not only is the fuel store larger, the boiler itself is much larger too. You're handling solid fuel here, not liquid oil or gas. We're finding increasingly in the market that's driven by RHI, there's often too little space to fit a biomass boiler, the fuel store, potentially an accumulator tank to store hot water, and all the ancillary equipment in an existing boiler room. Simply, they weren't designed for this scale of equipment. So often we're looking at retrofitting equipment in either a containerised version or a prefab plant room. The load profile is different for a biomass as well. I've mentioned about thinking about how far down you can modulate to. Also think that actually it's not as instantaneous as gas or oil is. So need to think about how you're getting your peak load. Might be well worth retrofitting a biomass boiler but keeping your existing oil or gas boilers in situ for peak lopping or for backup to cover you when you're doing planned maintenance. The choice of fuel is really chip or pellet, perhaps an energy crop like a miscanthus. Chip is a less dense fuel, as you can see. Pellet is much denser, much easier to deliver. Pellet tends to be more expensive, but the machines tend to be cheaper. So that well-known phrase, whole life cost, comes into play here. And fuel specification is important. Make sure you've got the right fuel spec for your boiler. We've covered the maintenance, I believe. So what should you be thinking about? What questions? Well, we've said, do you have the heat load? I just wanted to draw your attention to the top left picture here. That's a boiler between 500 and a meg from a Hever Castle, actually, in Kent. And the two big silver rocket-shaped things are actually accumulator tanks, each of which holds 10,000 litres of water. So I just wanted to give you a sense of, if you've got a heat load where you want to store heat, that's the sort of space you need for a really big operation. Do I have the fuel delivery access? Top right-hand picture shows a pellet tanker. We can blow pellets from a tanker up to 15 or 20 metres from the tanker to the fuel store. Gives you lots of flexibility on site about where you site your store, and also about the level of the store. The bottom left picture shows the doors opening from the ground there. It's actually a subterranean chip store. Ideally, if you're delivering chip, you tip it, which means you need your store beneath the ground to feed back up to your boiler. So it's a bit more complex to do it as a retrofit. Do I have the space? I think by now you've probably gathered quite likely you won't have the space in an existing plant room. So we're seeing products coming out like our own green heat module, award-winning at Green Build Expo last week, which is either a containerised or prefabricated module that you can site close to your plant room, depending on what space you've got. So exactly how much space are we talking about? Well, you can see there, up to 200 kilowatt boilers we can fit into a standard ISO 20 shipping container. And you can see the sort of footprint we're talking there, 6 by 2.5 by 3 metres. We then have a very technical term for the larger modules, the 3 parking space green heat module, which can take you all the way up to 999 kilowatts. And as you can see, once we get to the bigger boilers, it's a significantly bigger footprint, partly because we always include an accumulator tank, like you just saw at the photo at Hever Castle, and partly because, obviously, as the boilers get bigger, you need a decent-sized fuel store to avoid having deliveries every other day. In that instance as well, we can either have the fuel store above the plant room or adjacent to it, depending on how much floor space you've got available. So let's start talking about the pound notes. What are the key factors for getting some financial benefit from the RHI? Well, there's 4, effectively. Because biomass is rated as zero carbon, you get a reduction in your carbon reduction commitment, reduced use of counterfactual fuel, and I would emphasise that you look at this very carefully over the duration of the project, because the model is most sensitive to the fuel price that you're displacing. So if you're displacing oil or gas, it will vary the payback periods and the return on investment quite significantly. I'll cover income from the RHI in the next slide. But finally, for those of you who have the opportunity to do this, you can today use enhanced capital allowances to further improve your business case, so that you can use the first-year tax relief to help fund the biomass boiler purchase. So the RHI income itself, you can see the up-to-date tariffs there at 200 and above 1 megawatt. We've also got a sample calculation. If, for example, your biomass boiler was 199 kilowatts and you were going to run at 2,400 hours per annum on that boiler, you'd get 8.3 pence for the first 1,314 hours at 199 kilowatts, giving you just nearly £22,000. The remaining hours from the 1,314 up to the 2,400 would be paid at 2.1 pence. That's the Tier 2 payment, contributing another 4,500, giving you £26,241 in total every year for 20 years. And as I mentioned, once you sign up, that's there for 20 years, but the rates are varied with RPI. So those will go up as the RPI does. So quite how compelling can this be? The example I'm just going to outline here is based on one of our green heat modules that is not only financial compelling. Bear in mind, if you're displacing oil with biomass, you're probably only 10% of the carbon that you would have been previously. It's a turnkey piece of plant. The idea is it turns up on the back of a truck. It's everything you need in the box. We basically unload it. We hook up the flow and return to the existing plant room. Mains cold water, electrical feed, and away you go. You're generating renewable heat. It's got an integral fuel store. It's got one of those gentlemen's heat meters inside it, all the M&E you need, and away you go. If we apply that to, say, an office block that's currently using something like 1.2 meg of existing boiling capacity, let's say we leave the existing boilers where we are, and we use a new green heat module to satisfy the base load, the paybacks, I would suggest, are quite encouraging. And as you'll see from the slide, nothing says you have to displace the whole capacity. You could just go for a 199 kilowatt boiler and offset that portion of the load. If you did that against a gas boiler, we reckon the payback's in the region of about 6 years. And if you did it against a new oil boiler, about 4 years. We've used pellets to work this out rather than chip. And the other thing to bear in mind is if you're replacing older equipment, the efficiency is likely to be less, and therefore the payback will be quicker. If you're displacing 999 kilowatts on either gas or oil, you're talking about respectively 5 years or 3 to 4 years. So given that you've got 20 years of payments, quite an interesting proposition. If you don't want to use the capital, I would suggest you'd have a look at the marketplace, because there's lots of different ways to do this today. There are a lot of companies out there now offering to sell you in traditional ESCO way, energy services company way, heat in pence per kilowatt hour. But there's also flavours between that and a direct purchase, including buying pellets with a slight premium on it, but not having to actually own the boiler itself, just gaining from the reduction in the fossil fuel you've been buying. Or alternatively, there are companies out there leasing the boilers with buyback options at 5, say 10 years. Or, of course, a direct purchase. As I mentioned at the beginning, I just thought I'd show you a couple of slides at the end to show this is actually happening. So what I'm going to show you now is one of our green heat modules just deployed a couple of months ago on a large public building in the southwest. This is a 199 Hargassner pellet boiler. From this exciting angle, you can see the fill and vent pipes. So we're looking at the fuel store end here. On approach lighting, we've also thought about things, as you can see, a small panel in the bottom of it. That's in case in the 20 years of the operation you ever need to remove the auger, it's going to be very easy for you to do. Effectively, the unit's been brought, deposited on the concrete plinth, and the services are just about to be hooked up. You can see there's a 2-metre flue there as standard. There's also an explosion relief panel, because pellets are potentially explosive material in the same way as a lot of fine grain flours, etc. So they are subject, pellet stores are subject to the DSEA regulations, the dangerous substance and explosive atmosphere regulations. So important to have those sorts of measures integral in the unit that you get. You can see the red pipes on the side there, that's service entry, and service entry can be either through that side or from underneath. There are obviously sites where you'd want it trenched underneath rather than coming from the side. Looking in, we can see a Hargassner 199 pellet boiler there. The door that you can see is actually the door to the combustion chamber. Down bottom left, that's an ash bin. Another important consideration when you're looking at biomass, you will have to empty the ash bins from time to time, depending on the run hours you're at. If we go slightly closer in, we can see some of the M&E works inside the green heat module, including a plate heat exchanger. Again, we'd recommend this because it means you're not applying any additional pressure to your existing heat distribution system, and you're also protecting your new biomass boiler from that system and any rubbish that might be circulating in it. So it's a full plug-and-play package. If you'd like to know more, as I say, we're Wood Energy. There's my contact details. If you'd like to know more about how your business case could look, please go to that link there for a calculator that gives you the opportunity to play with different factors. And as I say, today we're in Hivar on stand V1. Thank you.